uh, I'm no doctor, but uh, uh, yeah. But let's get like I said, I wanted to start with a couple test questions. Kind of that first question that we did yesterday, and through the review, I kind of showed you all the different types of questions, doctor. So when we were reviewing, I actually, without you knowing, we were solving one of Dr. Asadi's test questions, and then I asked you all to solve another one, right? So yesterday you weren't aware of it. It seemed like you just got one Dr. Asadi question, but when I was asking you to write the equation for the magnetic field, that's essentially, he asked you to do it. He gives you some numbers. We didn't do it verbatim, but you got a feel for two different questions, two different ways that he could ask the first question, right? So, and those were both on yesterday's review. So I want to do the same thing for the second question. I want to give you some variety. And then again for the third one, if we can, also, give you some variety of questions. But I want to make sure there's time, and I also want to make sure that we cover that. We haven't covered any of the concepts. We got all the other concepts down, but we haven't covered the concepts for that last section. So I want to make sure that we talk about those before we answer the questions, because otherwise, you won't really have an idea. Or I'm sure you have an idea, but it'll give us a much better idea of how to solve the problems. And then also just keep in mind, as I was saying yesterday, because the way Dr. Asadi writes his questions, like most of the stuff you're going to be able to find the answer for. It's just going to be as easy as looking in your book, right? He's when he's writing a test question, he's looking at the worked out problems in your book, and he's trying to write a question where you can at least give something based off the problem. Because you have your book there next to you. If you're looking in your book and you understand what's going on, you can see what worked out examples and what parts of those worked out examples you need to, again, you might not know how it fits in, but as Dr. Asadi's been telling you, just write it down. Nobody asked you if, no one said don't write it down unless you know how it fits in. Dr. Asadi's been telling you all semester, like, if you're looking at an example in the book and you see that you're like, oh man, they're solving this question the way that they're solving the same type of question Dr. Asadi's asking me here, but I don't understand how they're putting the numbers in. Well, who cares? Don't worry about that. Just write the equations down that they're using. It will give you points for them, even if they're, they don't, to you, they don't make much sense. Write the equations down. And remember, no values, right? We don't put any numbers in until the very end, right? I'm not saying we don't put numbers in, but when you write the equation with just the variables in it, we give you points for that. You might be like, oh no, we need numbers in this, but not in physics. If you didn't learn that in physics 1, then definitely make sure that you understand that about physics 2 now. Okay. So just keep that in mind for the test, okay? When you're answering questions, okay? All 3 of the questions that he's going to give you, and this has been true all semester, okay? The second test, he kind of tries to make a little challenging, but the first and second, or first and third test, he writes directly off the questions in your book, and you should, like, the worked out questions. And then what does he do? He adds a trick in there. And that's what I was trying to explain yesterday, right? When he adds a trick in, it's gonna be the thing you're gonna feel like, I've never seen this before. He never taught this in class. I don't remember this part in class. Carl never talked about this in any of the review, right? And that's what he he that's how he makes the questions, complicated, because you can, if you're smart and you read it, you find you're able to correlate the worked out problems in the chapter to the question on the test. You're going to have a lot of the work done. You're going to get a lot of the points for the question. And so what really is going to be setting you apart from everyone else, right, is how much of the trick, right? Every question has a trick. So who is able to kind of solve it? They're more like, I shouldn't call them tricks. They're like riddles, right? He puts like riddles in the question. It's like, it's stuff, but it's stuff, it's like, well, I didn't learn about this here, but I do know, like yesterday with phase shift. It's like, well, yeah, I do know phase shift. We never talked about it in the chapter with this, but yeah, it's there. And in the question, it's like, yeah, I guess when you think about it, it is there. So those types of things. It's something that right? You know the answer to, but to what it is and what you have to do to get to that point. That's where the critical thinking comes in. And you got to kind of literally like use your imagination and kind of go through everything in your head and go like, well, does this apply? Like, just don't look at the question and keep reading the question over and over and reading the givens, thinking like something new is going to pop into your head if you read those things enough. Nothing new is going to pop in your head. What you got to do is critically think. You got to sit there and read the question and say, okay, what else could possibly be going on here that I'm not seeing right now, right? Like, what's this question about? What's this question related to? What other things could be happening? Again, like using the question from yesterday, the electromagnetic wave is a wave. So why the heck couldn't there be a phase shift, right? You see what I'm saying? And so that's the type of thing, right? You're solving that electromagnetic equation and you go, oh, this thing has, you're trying to figure out, well, again, remember, all of us wanted to move forward. We didn't even know there was a second part to that. So I guess my other heat of caution is if you're working through a Dr. Asadi problem and you're just getting the basic stuff, I'm telling you right now, you should stop and say, wait a minute, this is a Dr. Asadi question. There's something, I got to be doing something more. And, maybe you don't know what it is. And one good idea is to kind of, please listen to this part because this is very important in terms of strategy. Go through each question and answer the stuff you can. Don't spend all your time on one question or two questions. Okay? You can go through each question and write some equations down. You want to make sure that you have something written for all three questions. Okay? And the best way to do that is to just, solve the stuff that you can about the question, move on to the next one, solve the stuff you can about that. Or even if it's stuff you can't solve, what I mean by that is just write the equations, right? Look through the chapters of your book, find the questions that are relevant to the question he's asking you and go, oh, okay, I don't know how to put these in there, but I see in this question, they're using this equation and this equation. So that means those two equations are important. I better write those down as part of my answer here. I don't know how they go into anything, but I know if I just write these equations down, they seem to be important. They're solving it. They're using them to solve the problem in the book. I'm going to get points for those equations rather than not writing anything at all because you're like, well, I don't know how those fit in, so I can't just write those. Dr. Asadi's not going to give me any points. No, he is. Just write them. Just write the equation down. Okay, as you look through the questions in your book and the worked out questions in your book, you're trying to correlate into the question on the test. You see something that looks it looks very close to something on the test, and you're reading it. And you're like, I don't know. You're looking at the numbers and you're like, man, those aren't the same. He didn't give me the question they're solving in the book gave me different givens than the givens that he's given me here on the test. Don't worry about that. That's what we're trying to tell you. Okay. Just write down the equations that they're using in that question that's solved in the book onto your test. Okay. Just write it down. Okay. You're going to get a lot of points for that stuff. Okay. And then after you've done that for each question, okay, all you're doing is reading it, looking through your book, trying to find the questions that match up with it, or something that's kind of close. It seems like, oh, they're kind of solving for the same thing. Just writing the relevant equations down. And then once you've done that for all three questions, go back to if you can solve them all the way through, please solve them all the way through. But, if you're reading the question, you're like, I don't know how to solve this thing, just make sure you get some equations written down for all three, and then go back through and then try to solve them deeper. Okay. All right. Very, very important. Very, very important. Okay. It's just, I tell you these things because I understand you all come to a review and you want to know the review and you're like, let's sit here in the review. And I'm not saying that they're not helpful, but the thing is that the stuff that we do in here, it might not look anything like the test, like nothing. And I want you to be able to still, not panic and go, well, I don't know what to do. Okay. I want you to be able to at least give us something. Okay. Even though it's like you're reading the question, you're like, man, I don't know how to do any of this. No, Carl told you that, and so did Dr. Asadi in a way, told you that these questions on this last test are going to be directly related to the problems that are worked out within the chapter of the book. Okay, so, all right. All right, so for this first question, and again, I want to give you, I can't just solve it. If he hasn't posted the slides for chapter 25, you should email him and let him know, because he's a busy man, and when you all see him, he teaches all day on Tuesdays and Thursdays. So he teaches 4 hours before you all see him. And when he's done with class at the end of your guys' class, he's been teaching for 8 hours straight. That's Tuesday and Thursday. And then he doesn't get a break. His other class ends at 12 and this one starts at 12:15. He can go to the bathroom and then he has to start teaching again and just sit there for another 4 hours. So, and then he's doing his research and everything else. He's a busy guy. So please email him because he has a lot on his mind and he's doing a lot. And sometimes he thinks he did something and maybe he didn't do it. Okay. All right. So this is like I said, I'll write the question down. If there's pictures, I'll always give you a picture, but if there's no picture, okay, then suppose the position, object to a concave mirror. Sorry, I want to make sure changes. Find the ratio. The image distance size for these two cases. And then he says repeat problem for convex mirror. So first, okay, so let's read it all together. So suppose the position of an object to a concave mirror changes from P is equal to 0.5 F, which is 0.5 of the focal point. Okay, that's what that's saying, to 0.25, right? So it's going from, half the distance of the focal point to 0.25 of the focal point. Find the ratio of the image distance to the size for these two cases. Repeat problem for convex mirror. Okay, so I'm going to give you a second to digest, kind of write some things down, kind of practice. Please use this for practice. If those of you who are going to watch the recording of this, pause it right now and practice looking through your book. So you're not just doing it for the first time on the test, right? Practice looking through your book, finding the relevant questions that's solved in the chapter that are going to help you for this question and writing those equations down. And then unpause the video, right, or whatever. But, and everyone here, please just, I'm giving you time right now, go practice that. Right? If you know what to do, then write down what you need to do. Don't waste your time doing something if you don't need to do it. But if you don't know what to do, please, that is the biggest hint I can give to you. If you're sitting there going, well, I don't even know what the heck to do here. Please look in your book. Please look through the questions in your book, the worked out questions within the chapter. Find something relevant. Okay, I'm going to be quiet, give you about 5 minutes here. I don't know the numbers, chapter numbers. Hold on. I'll find out. Hold on. This is chapter 23 stuff. We haven't talked about the chapter 25 stuff. That's what I was saying. We haven't covered the concepts of chapter 25 or anything yet. So we still got to cover the concepts of chapter 25, and then we can solve problems for chapter 25. So this is for this question is chapter 23. But remember, I shouldn't say 23. I'm so sorry. For this question, it's a mix of 23, 24. Okay, so the third question on the test, you're asking a really good question. So for the first For the first question on the test, it's going to be over chapter 22 specifically. Okay. Because we can't mix that. That chapter kind of stands alone. And then these last two chapters stand alone. So for the second question, the question is going to be from a mix of chapter 23 and 24. So you want to look at everything there together. Okay. And then the last question will be on chapter 25. So I'll be quiet, let you keep looking. But it should be obvious, again, if you've studied and you've looked through the book already and it's all tabbed up to you, you should know where to find this stuff, right? Remember, I told you all to tab your book with the information, because if you see a question that's about something specific, you should have a tab in your book that says concave mirrors. If you don't, I would. Right? And you can flip right to it. This is what the question's about. You won't need to be searching, or you'll know exactly where to search, maybe, instead of just flipping through the pages. Okay, I'll be quiet. Sorry, I was talking there and I thought I unmuted myself and I didn't. What do you mean? I was talking there for a while. What do you mean the M of the mirror in two cases are the same? I mean, did you solve for them? I don't know. What were you given here? You were told that the concave mirror changes from P to P, right? Right. Like right. You have the mirror, right? And you move the yes. Hold on. 1 second. Put my pen down. No, I can't find it. There we go. Um uh uh right. You have this object, right? And um, you know, oh, it's concave. So you have this, concave mirror, right? And then let's do it like this. Have it here. That's where P is equal to 0.05, and then you move it, right? Then you bring it closer. Where P is 0.250. So that's what's going on. Does that make sense? So you're moving it. It's the same object. I want to say much. I want you to solve this because I'm going to ask you what you need to do to solve it. But that's the situation. So yeah. So you're seeing you're saying what M is, right? Okay. So all right. So do you feel comfortable? You want to start trying to solve it? You got some stuff written down? Like, don't throw it out at random to me, okay? Don't just as we get to the point, just start trying to figure it out. Then make sure you have something figured out, okay? Because if we're sitting here, if I give you time to think, like I want to try to make this go as fast as possible. And if we're doing thinking while we're trying to solve it, I want you to kind of have some thoughts in your head. Do you have thoughts in your head? You ready to go, or do you want a little bit more time? It sounds like you're saying good things, but I want you to know for sure. Like, tell me, like, imagine this was the test. Like, how would you solve it? Don't worry about me. I'll make sure we get to the right answer. But all I want you to do, and this was the same thing as yesterday, right? Is imagine this is the test. Okay. I'm just going to write things down that you tell me to write. I'm not, okay. Like I said, I'll make sure we'll get to the right answer, but I want you to, that's why it's nice when there's more people here. So you're not so much on the spot. But do you want a little bit more time? Um, yeah, that's the ratio, right? That's the image distance to the size distance, right? So Q1 over Q2. I mean, if you're asking me, right, that's what it says here, right? Ratio of the image distance to the size. So is that correct what you have written there? You tell me. That's what I mean. Like, I want you to not ask me. I want you to tell me what to do. Don't ask me what to do. Does that make sense? Okay, good. But you're just asking about the right. There, he wants you to solve for the image distance. And what's image? Q, right? And then he says image distance uh, to the size, right? So what is that? You're giving me a lot of equations. I want to make sure that you I'm waiting for you to tell me what to do here. So what is he asking you to look for? You sent me a lot of equations. Like I said, I want you to tell me what what I should write. It's going to go really slow if you ask me every time. Imagine it's the test. I mean, the test is tomorrow, so you should have a good idea of this already, right? Hopefully you're not trying to get it all down today. So what's the when he asks you for the image distance, the ratio of the image distance, what is that? Just start with that one first. What is that? Tell me confidently. You should know. Good job. See? See? You know. That's my point. See, that's why I want you to do this. It's not because I'm trying to be like, come on, what's wrong? No. It's because I know how freaking smart you are and how smart everyone is. You know this stuff. Don't when you rely that's the problem when Dr. Sunny or I solve problems with you is you guys rely on our brains and then you all kind of let yours kind of not do the things it needs to do. But you know. Okay, so that's one of the what's the other question he's asking you for? Hold on one second. What's the other thing he's asking you for? Sorry, I wrote that backwards. It's Q2. No, he's also asking you for the ratio of the size. What is that? So this right here is the ratio of the image distance, right? He's asking you two questions. What's the other one he wants? No, there's another equation that he's asking for. What equation is that? What's the second thing he's wanting you to solve for here? I think you are confusing this with this. I wouldn't do that if I were you. You keep focusing on that, and I think you're confused. He's not asking you for an equation in your book. He's asking you just for the ratio of these two images, which is Q over Q, right? I don't know of an equation in your book that tells you that. Do you? So I think you're thinking this is a different equation, right? And then what's the other question he's wanting to solve for? There's two. He wants the ratio of the image distance and size. He wants the ratio. He wants the ratio. He wants the ratio of the image distance, which is what this is, and size, which is, if you read that separately, if that's confusing, find the ratio of the image distance and find the ratio of the size. What's the other thing he's asking you for?
I don't know what do you mean the ratio of the size.
Well, what variable do we use for size? I'm pretty sure that's in your book. The ratio isn't, but we give you that relationship. So the relationship um, uh, um, uh, trying to find it in your book. I don't think I'm going to be able to find it in your book, but it's uh, it's H height. Essentially, these have a certain height to them, right? I'll just explain it to you. I can't find it right now in your book. But right, and so this is going to be the height one. This is going to be sorry, this is the object size. He's asking for um, the image distance and the image size. So he's not looking for these things are going to make, right, they're going to do some right, there's all those rays that form, and these are going to form two images, right? And these images, they're going to have a certain height to them. Does that make sense? Right, but I read it 5,000. Remember, I repeated it like 9,000 times that this was size. I mean, you can say what you want to say, but I repeated that over and over, man. I read this to you over. This is being recorded. We can go back and listen to how many times I read that. I said that was size. Okay. And so instead, right, these are gonna be H and H. And these are going to be H1 prime and H2 prime. Okay, so we're looking for the other question answer that we're looking for is this. Does that make sense? That's the question that's being asked. Right, because it's always an initial over final, right? Like the first one over the second one, you always do a ratio like that. I mean, it's depending on how you want to set up your ratio, right? But we're seeing how, I mean, either way, you can actually, I should say it like this. Let me say it like this. Is you could set this ratio up either way. Just make sure you understand what, the answer that you're getting. Here we're looking at Q1 to Q2. We're comparing Q1 to Q2, but if you compare Q2 to Q1, you should get the same answer. You're just finding the difference of Q1 to Q2 instead of Q2 to Q1, right? But they should be the same answer. You better not get a different answer. I mean, I guess what I should say is that the numbers aren't going to be the same, but like the differences, right? Q1, the difference between Q2 and Q1, you're going to see that difference between when you compare Q1 to Q2 to Q2 to Q1, right? This is just going to, again, we spoke about ratios before. We kind of have to, if we want to stay on pace, we got to move forward. But that's how ratios work. Okay, we should understand how ratios work. Essentially, you're always comparing the bottom, whatever on the bottom to on top, right? That's why when they tell you can never divide by 0, the reason why is because you're trying to say, if you understand this, what this is telling you, you're trying to find 5 parts of nothing. It doesn't make any sense, right? That's what a ratio, when you understand a ratio, what that is. Okay. So, all right. So what do we got to do here to solve this? He wants Q2 over Q1, right? And then he wants Q2 over Q1. So what do we need to do to solve this?
You see my equation, yeah?
What was that?
You see my equation in the chat.
I cannot hear anything you're saying, my friend.
Oh, sorry. Do you see my equation in the chat?
I do. Okay. I mean, we can start there. I don't know how you're going to start there though. You don't. That's fine. I'll write it down. If that's how you want to approach it, that's fine. But hopefully you see something very quickly. Oops. Okay. Now what? Do you know M?
Yeah, it's the same thing. So
You can't just say it's the same. What are you talking about? What do you mean it's the same? You said that before. What does that mean? I don't even know what that means.
That is from the year.
Um, so do you know M? Just answer. I always ask questions. You never answer the questions I ask. Try to just answer the questions I ask.
M is the
Going to make things a lot easier for you. What was that?
M is the magnification. Of
I,
the,
you're cutting in and out, my friend. I cannot hear you very well. No, I know what it is. I asked you, do we have it? Okay, that was my question, right? Do we have P2? Okay, do we have Q1? Okay, so this, how are we going to be able to start with this equation, I guess, is my question. We only know one thing about it. Okay, I'm not saying we're not going to need it. I'm not saying that we don't need it, but I don't think that's a good place to start. Does that make sense? I'm not saying the equation's not important. I don't know how we're going to start there. And if you want to explain, go ahead. Like I told you, you should be giving me explanations to your answers. You shouldn't just state something. I always have to ask you, okay, and then explain. Okay, you should just explain your answer every time. So if you do want to start with this, that's fine, but tell me what to do then. What question are you trying to answer right now? Let me ask you that. We already decided that this equation should not be used right now, right? So our brain shouldn't even be in it. That's what we decided, right? It's not that we won't use it. It's just it sure as heck isn't going to help us right now, right? If this was a test and you didn't know what was going on, you should definitely write it down. I'm not erasing it, right? I'm keeping it there. But I think we decided that that's not the place to start, right? And so I want to ask you, I want to see where your brain's at. Which one of these two questions over here are you trying to answer right now? Okay. Then how would you do that? How would you solve for Q2 over Q1? We already decided this cannot be used over here. Okay, I hope I'm not you were cutting out. I hope our connection is clear. Because this is important that you hear what I'm saying so that you're not, I'll say something and then you do it. I want to make sure that that doesn't happen. I want to make sure I'm catching some of your mistakes before you make them. Okay, can you hear me clear? Is everything clear? Okay. So we decided not to use this. So please, for the love of Pete, don't go back to it. Not right now. I'm trying to remember, I told you I wouldn't even be doing what I'm doing right now, but I also said I want to make sure that we get to the right answer. So it is important. Will we need it for this question? Yes. But how should we start this question? How can we start to solve? We need Q2 over Q1, which means what should we try to solve for first? If we need Q2 over Q1, what should we try to solve for? Q2 and what? Q1 individually, right? We need these two numbers. So you should try to solve for them individually some way. Okay, does that make sense? Okay. Now you said, what about this way, Carl? And I said, you know what? That's an important equation. But we went through, we looked at everything in there and we said, we don't have really enough to try to use that to solve for Q1. Again, is it important? Yes. But we don't have enough information to use to solve for Q1. So okay. So then what's another way that we could go about it? What's another way to solve for Q1 and Q2? And I believe you just gave me the equation. Yeah, I mean, we know that. Let's write it down. Again, like I said, we're trying to solve this like a Dr. Sadi question, right? Or like you're taking the test, not me for you. Okay. And so this is what you should do. You should write these questions down. Lauren, we're just solving this question. I'll read it for you real quick and then we'll get back into it. But it says, suppose the position of an object to a concave mirror changes from this P, which is object distance, right? It's 1/2 the focal point. And then when we change the position, the object distance, it gets essentially closer, right? And then the question is these are both object distances though, right? Because that's P. So find the ratio of the image distance and, even though that's not written very clearly, and size, right? So he wants the ratio of the image distance and the ratio of the size, which is Q2 over Q1. And I have this picture explains that not very well because I don't have this drawing, but these objects are going to have heights to them, right? And these are going to be like the H, prime 1, H prime 2. So you have these the heights of the object. These are the objects, but these are the images that they're forming, right? So we don't want H1 over or H2 over H1. We want H2 prime over H1 prime. Okay, that's what we need to keep in our head. And there's equations that connect us to all this stuff. Okay, but we just want, remember I said that this stuff, these last chapters, you're going to go about solving them entirely different than you would, the previous stuff. There's no Newton laws and draw your free body diagram first and stuff like this. Like you can draw, I drew this picture to be helpful, but this picture is kind of irrelevant. You really don't need it. Like there's nothing else to add to it. And if that doesn't help you, there's nothing else to draw, and you really don't need a picture. No one's asking you to draw one, but that's just to see stuff. It's really just about, giving him what he's asking for in terms of the equations. Like we've been talking about in SI and the reviews, that just use the equations. So we decided, right, that we need Q2 over Q1 and H2 prime over H1 prime. So in Q2 over Q1, that's the first question being asked. But lo and behold, and I haven't said this yet, if you tried to solve for H2 over H1 first, you would get to a point where you would realize you would need these. And so you would have to come back and actually solve the first problem anyway. Not that you could. We haven't done that. It hasn't been suggested. But because I gave the option, which one you want to solve for, I asked, and we went with the first one, which is a good idea. Okay, but I didn't mention that yet. So that's where we're at. We just said we said, okay, this is a good. He brought up this equation first because it has Q1 in it, right? And he was thinking, he told me it twice. He said, this is, and then we could do the same thing, right? So this has, oops, not Q1. Sorry, I wrote the wrong subscripts here. I don't know what the heck I'm doing. It's a good thing I went back to it. Okay, so there we go. It's written much better. Right. So we have a essentially, we was thinking concept. He's like, okay, both these mirrors are going to have, a certain type of magnification. These are the equations for them. But clearly, he was trying to state something. I didn't address it, but we can, hopefully you see it now, that he's trying to say that the magnifications are the same, but Q2 over P2 and Q1 over P1, I don't know if those are going to get us the same numbers or not, right? So I would be very careful about saying that they're equal. I know you're thinking, well, it's the same mirror, right? But if the image is getting closer to the mirror, things are changing. Does that make sense? And that's essentially the idea. Anyway, so he said, what about this one? I know this equation has Q1 in it, right? And then, you would have it for, like we were talking about yesterday in the review, you would have this for both for both mirrors, right? This or both positions, right? This is the first position. It's the same mirror, but this is position 1 and this is position 2, right? This is essentially where P, I should write it, right? He said P is equal to 0.5F for this top one, and then P2 is equal to 0.25, right? 0.25, right? Why can't I find it? Yes, 0.25F. Okay. So this is, so, okay. I mean, I don't know. We can go through that. We know we're looking for Q1 in here, right? We do have P1, so that's a good thing, right? So we really just have one unknown in this equation, right? This is where the math idea kind of comes in. So based off of the givens, right, we look at this and we might say, okay, I don't have a number for F1. So if I were to, let me give it a little bit more space to pennies. We gotta show some work here. So if I needed to solve for Q1, right, or we could start with 1 over Q1. That would be 1 F1 minus 1 P1, right? And then the same thing for bottom. Q2 would be 1 over, or equal to 1 over F2 minus 1 over P2. Okay. Now your givens are going to be really, really helpful here. Like it might seem like, well, I need an F in order to do this subtraction, right? So essentially it's like, oh man, I can't get Q1 this way neither because I don't have F1. You might tell yourself that. Okay, but based off the givens, do we need F1? Yeah, like the F is in there. So essentially we were given P1 in terms of F. So we don't need F, right? Because we were given P in terms of F. So we're going to be able to do the subtraction here. Does that make sense? Because we're going to, they're going to have the same variable in it. Does that make sense? It's essentially 1 over F minus 1 over 0.5. Does that make sense? Is everyone comfortable with what just happened? So over F1, and this is going to be minus 1 over 0.5F, right? So now we can at least, we're going to get an answer for Q1 in terms of F, but at least we can get an answer for Q. Does that make sense? Same thing down here. Oops. This would be F1, since this is P1, this would be F2, since this is chafing. So well, let's do the math step by step here. So what's oops, I wrote these in terms of 1. They should be 2 down here. So what's the top one? What's 1 minus 1 over F1 minus 1 over 0.5 F1? What's that going to be equal to? Be very careful here. Make sure you're doing your subtraction correctly. What's the next step? This is math, so I don't mind doing this for you. What's the next step here? Good. Factor out 1 over F. Good job. Okay, so when I do that, what does that mean? I'm going to have 1 minus what? Okay. So what's 1 minus, what is this number here? Oops, I was looking at that 5. Yeah, it's -1. Okay, that's what this is. Let's just write it. Oops, I wrote an equal sign there. I didn't mean to. Sorry. This is -1 times this. So what is 1 over Q1? What's it equal to? -1 over F, right? So don't cancel out those F's. Do you see where you went wrong? Okay, well, so then we're not done. That means Q1 is equal to what? Good, -F. So that's Q1. So we got an answer for Q1. All right, now what about Q2? Do we solve it the same exact way? Oops. So that's going to be good job. So this math, if you want to know it, to make sure that you're getting the right answer, should be this. You should be getting this. This is -3, so it's -3 times 1 over F, right? And then so that means 1 over Q. I'm going to work up this way. Is equal to, -3 over F, which then Q2 is equal to what? -F over 3, right? Okay, so we got Q2 and we got Q1 and Q2. So we have our answer, right? That's the first answer that's all we were looking for, Q2 over Q1, right? So we know that now, right? We know that Q1, right, is equal to -F. We know Q2 is equal to -F over 3. So then we want to do Q2 over Q1, right? So what is that going to be? That's going to be -F over 3 over 1 over -F. These are going to cancel. Q2 and this is what I mean about understanding a ratio. So what is this telling you? What's that mean? Because remember, you were asking me, Carl, why not Q1 over Q2? So we see if I did Q1 over Q2, I'd get 3. And remember, I told you that these are the same answer. Or I told you they were telling you the same thing. I said, saying they're the same answer isn't the best vocabulary. But I told you these answers are telling you the same thing. Can you now explain to me what I was trying to explain? Do you see can you use these answers to explain to me what I was trying to explain to you about ratios? Because it is important that not just you, but everybody in this class understands what a ratio is. And remember, anytime you divide, that's a ratio. Since you've been dividing since elementary school, all you've been doing is taking ratios. Nobody told you how to teach not in this country, but that's the idea. It is the relate, but what is it? What does it tell? I understand that, and that's what we've been saying is that it is the relationship between the two. But what is it? It's telling you something. It's saying something to you. What is it telling you? Remember, if it was just the relationship, how are these the same number? It has to be saying something else, right? There you go, my man. So, and Lauren, please let me make sure that this is making sense as well. We were just discussing this earlier, I think, before you were here. But so when you write this ratio this way, right, you're saying it's 3 times the size, Q1's 3 times the size of Q2. Good job. But if you write it this way, you're saying Q2 is a third the size of Q1. You see how they're saying the same number? Do you see what I'm saying? They're saying the same thing in a different way, right? You see what I'm saying? And that's the thing with the ratio. So you asked me, Carl, does it matter if I do this? Who needs to go on top? That is such a really good question. And my answer is to you, if you know how to read this thing, then it doesn't matter. Do you see what I'm saying? But if you don't know how to read it, then it totally matters, right? Because you're going to be, if you only see this one way, then you need to write it the way that you see it. You know what I'm saying? Does that make sense? Awesome. But if you know what it means, then it really doesn't matter if you're doing Q2 over Q1. This question came up earlier because it says to do the ratio, and I wrote Q2 over Q1 when we were stating it, and we said, why not Q1 over Q2? Why are you writing Q2? Why are you so specific there? And I told him it actually doesn't matter. I was just writing it this way. You could write it the other way, and so now we understand what that means. Okay. Okay, great. So that we got the first answer done. It's done, right? This is 1/3, right? But if you do it if you did Q1 over Q2, you should be getting 3. But either way, the answer means the same thing. Okay. So now we need H2 prime over H1 prime. That's our next goal. How do we do that? I'm gonna have to erase all this work we did. What's your suggestions, either of you? And please take your time, think, look, and remember the thing, Lauren, I explained this before you got here, but it's something that, when you hear this recording, and obviously the one from yesterday, I'm stressing it, is that I'm really trying to use these times for you to take this test like you would during class. I know I'll make sure we get the right answers, but I want you looking through your book. Every question that Dr. Asadi is going to ask you on this next test is going to correlate directly to the worked out problems in the chapter. And so even if you don't know how to answer the question, at least find the questions that he chose from the chapter to write that question about on the test. And then just for, even if you don't know why you might be looking at the question saying, man, the questions solved in the book used entirely different givens than the questions Dr. Asadi's given me. Don't worry about that. Just write if there's important equations that they're using, you're like, man, that's an important equation. You're looking at the work, write that stuff down. Okay. Maximize your points. That's really what we're doing right here. So right now, when I'm asking you, like, what should we do? We need these 2 things, or we need this ratio, not 2 things now. We just need this ratio. If you're not too sure where to start, like, look through your book. The second question is going to be on chapter 23, 24. This one's leaning more towards the 23 side. I will say that. But you won't know that on the book. On the test, you should just know that the second question can pertain to 23 and 24 as a whole. And there are another question I wanted to ask you about this, the second, a different question that I've seen him get, another that looks entirely different than this for the second question, but I have a feeling we're gonna have to talk about the concepts first and then swing back around to that based off the time here. So how should I solve this? I need h2 prime over h1 prime. Is there anything in your book that's hitting you anywhere? Good. So that's a really good point, is that we just solved for Q1 and Q2, right? So here, right, it looks like we're at the beginning, when we were trying to solve this, which it was a lot more difficult then, right? All we had was essentially P1 and P2, right? And so, but now, yes, exactly. You're making a fantastic point. You're like, oh man, well, we have all the P's, we have all the Q's, right? You're saying fantastic things. That is exactly where your head should be. So how can we go about using that to solve for this answer here? And since again, there isn't like free body diagrams, there really isn't much physics. It really is just some mathematics we got to do, and it's not that hard, just as long as you know what equation or what equations I should say you need. But solve what? What are you talking about? I have no idea what you're talking. Just plug it and solve for h prime 1 and 2. What are you talking about? I don't. That's what I need. This is the answer I'm looking for. How do I plug those in? All right. Again, my friend, I would, like I said, I'm trying not to help you too much, but I do want to guide us into the correct direction, right? I'd be very careful about what you're saying right now. I mean, I get so you're saying good things, I guess. Maybe I should say that, looking at your equation there, but look at it before, like, look at it. Do the things that we did. Don't make me go through that same process again, right? I'm not going to be there on test day. You should have a natural way to try to figure out, like, is this the equation we want right now? I shouldn't need to show you how to do that. Am I saying it's not useful? No, that's not what I'm saying. I'm asking you, you're telling me to just solve for h prime. Okay. Using that equation that you typed, but please look at it for a second. Can we do that?
No.
Can
you hear me?
Slightly, a little bit better. Yeah.
So
I'm going to write the equation down. Okay. But I want, as I'm writing it down, I want you to, again, or maybe I don't understand. What do you mean solving for h prime yet? Maybe I don't understand. Okay, you're saying we can't use this to solve for H prime yet. Okay. Okay. Is it useful? I think if you were working the test right now, right, I would definitely write it down. Even if you didn't know what to do, or even if after you played with it, you're like, I don't know, I think I can't use it. No, I'd keep it written down. I think you can. Go ahead. I believe you can. You should just be able to write on it. Hmm. Yeah, I don't know. From what I know, you should just be able to just start if you have, if it's enabled. It is enabled. I didn't turn it off. But anyway, what's something else we can do? So this might be. We see that we have right. We have H prime in here, and you're saying, hey, why not? We have Q and P, right? Oh, okay. So solve this for H prime, which means H prime is going to be equal to, H over Q over P, right? But do we know this H? Okay, okay. See, that's what I mean. You explain your answer to me. You see what I'm saying? Remember, I said if you just give me this equation, I told you I was just going to write it. You got to tell me what you want to do with it. Does that make sense? So you're saying get two of these, one for each situation. So you're essentially saying this is going to be H1. And then we'll do the same thing for, and this is going to be Q1 and P1, right? And then this is going to be Q2 and P2, right? And what is this H right here? Like, what is the H? Not the H prime. What is the H? Object size, right? So are we changing the object here, or is it the same object? We're just moving it closer, right? Right. I just want to make sure everyone, if they watch this recording, they understand what you're saying. Okay. Because I want you to explain this and you're not. And I know that I know you can. I wish you would at least type it. I'll read it out. But this okay, so let's write this. So we know H is equal to Q2 over P2, right? And then we know that H1, right, which is on the bottom, is going to be equal to H Q1 over P1. And then you're saying these are going to cancel, right? And then we're left with Q2 over P2 and P1 over Q1, right? Multiplied by themselves, right? Maybe I should write that. Okay, so now what should I do now? That's what I'm waiting for you to tell me. That's what you told me to do, right? Okay. Okay, so you said that Q2 over P2, and this is something we solve for, right? Right, Q2 over Q, or I'm so sorry. Oh, I erased that work. Gosh darn it. I erased it too early. But, oh wait, no, right here. This is one of them. Right, so we know Q1 is equal to negative F. We know Q2 is equal to negative F3, right? So we know Q1 over Q2 is 3, and we know Q2 over Q1 is 1/3, right? So hold on. So this right here we're saying is 1/3, right? And then we're saying that P1 over Q1, what's that equal to? Oh, I'm sorry. This is Q1 over Q2. I'm writing that. I'm so sorry. I'm so glad I caught myself there. Those are Q's over Q's, not P, not, I'm so sorry. I'm so sorry. I think I apologize about that. I don't think we've solved for Q1 over P1, have we? I think I confused myself, but do we know what Q1 over P1 is? So, right, you can, right, we know what Q1 is, we know what Q2 is, we know what P1 is, we know what P2 is. Right, Q1 is F, Q2 is, F over 3, P1 is 0.05 F, and 0.2 is 0.25 F. So good. So what you would do, right, is you would put all those numbers in here, and what do you get as an answer? So, Q1, this would be, this would be F over 3, P2, right, is 0.5 F. Anyway, let me just ask you, that's gonna, now I'm really taking a lot of time. When you put all those numbers in there, so F, right, what do you get as an answer? So we're gonna have 0.05 F up here, F down here. P2. F. I'm writing the numbers for you to help you. I want to make sure that you put the numbers in your to your okay. Okay, so what is that number? Obviously, all the F's are going to cancel. So it's, you're looking at 0.05 or 3 times 0.25. I would get a number for 3 times 0.25 and then divide that by 0.05. What number are you getting there? Oh, I'm sorry. You're right. I copied that over wrong, didn't I? You got to watch me. Okay. What are you getting? What are you getting for, right? Maybe I shouldn't do it like that because I think when I do it like that, it plays with you and you don't know how to put it in your calculator. So where I don't want to spend time on this. We really should move past this. We're done with the question. We have the answer here, but let's just make sure we are doing it correctly here. So what's 1 over 3 times 0.25? So do 3 times 0.25. Multiply those two numbers first. What is that? Good. So that means that this is equal to 1 over 0.75. Okay. Now, for P1 over Q1, right, that's going to be it's going to be F over yeah, 0.5. Okay, yeah, no, I think you're getting it correct. I think I was, now that I'm looking at this math, I think you are. You're you're good. So 0.5 F, sorry, I was looking at that. So this right here, what's this equal to? Sorry, I was doing it in my head before I wrote it. I just want to make sure that. Good. Okay. Now divide 0.5. Okay, cool. I just wanted to make sure. I don't know why that number didn't sound right to me at the beginning, but good. Okay, good. So that's 2/3. So that's the answer then. Sorry about that. I just wanted to make sure that we were getting the right number there. So good. And that's H2 prime over H1 prime. Okay. So So there's another part to this question, right? That was just the first part of this question. There's another part that says repeat the problem for convex. Okay. So just do everything that we did. You just repeat every step that we just did. You do the same exact stuff. Do not do anything different. Okay. If you're like, Carl, show us. I just showed you. If you do something different than what we just did, right? So if for this recording, like rewind it, watch everything we did, do the same exact thing. Okay. But does anybody know what's going to be different when you use a convex mirror? There's only one concept that you got to use for this question. Yeah, the sign. Good job. And what the sign of what? Okay, is it the sign of Q1 and Q2? Are you remember, I hope you're not guessing. I really, really hope you're not guessing, because there's no guess here. Where should you be looking for this answer? If it does have to do with the sign, right? We said, yes, it does. It's a sign thing. Where are you supposed to be looking right now? Is it a guess? Is there an equation to solve? You should be looking at those charts in your book. Remember, I told you the ones that you need. I told you, if you don't know those charts that give you the sign, remember I told you those charts give you the signs of everything. And that's the only way to get them. You don't do anything else. There's no math you're going to solve. Well, you can solve equation, like, if they're asking you to solve for Q, and it's like you're forming a real image, then it better be negative Q, right? Stuff like that when you solve for the answer. So you don't want to put the negative sign in at the beginning because you're trying to solve for that value. But so, and we know for this question right here, right, you have to keep in the back of your head, based off the work we just did, you're going to be using Q. You're going to be solving for Q. So you don't want to change the sign of Q in this equation because you're solving for it. Just like the last question, we didn't even change any signs at all. I didn't even bring this up, right? Because I was asking you how to solve this and it wasn't even brought up, but now it's an issue, right? You didn't have to really bring it up last time because there were no sign changes, but that's a dangerous game to play. You should always, 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 always check. So at the beginning, the first thing you should have done for the first question is you should have checked signs. Okay. So you should have went and checked the tables and said what signs are everything supposed to be. And then you should have said, oh, they're wanting me to solve for Q. So I don't want to play with the sign of Q at all. But P and F, if those need sign changes, I need to make the sign changes. Otherwise, when I do the mathematics, it's not going to be correct. And then once you've made the sign and you're trying to make the sign changes to this equation right here, right? So if you're trying to solve these equations for Q, then that means that you don't want to give Q any sign at all, but P and F, they need to have signs before you do the mathematics in this equation or for this question, or any question using this equation. Does that make sense what I'm saying? Okay. So now you need to look at those tables. We're not going to resolve this problem again because it's literally all the work we just went through. I would just repeat myself. But the one change you have to make is what? What sign change do you have to make? That's my question. You're gonna use these two same equations right here for the next question. Using the same exact way. Using the same exact way we use them here, except they're going to need sign changes. So for the second part of this question, what sign changes do I need to make to these two equations here? Before I start to solve them like I did, like we just got done doing with this previous question. Good, the focal point needs a sign change. P does not need a sign change. Now, what does that mean? Right now it's positive, so if it needs a sign change, it needs to be negative, right? And where did that come from? Your table, right? So now you see how important that thing is. If you haven't looked at those tables yet, then now you see, because you would have left this important thing out. Because you didn't even bring it up last time. I mean, for the first part, right, was to like, always check your signs, right, for P, Q, and F, what they need to be. And also you can use that idea to check your answer here, right? What should Q be? And when you solve for Q, right, what should the sign of Q be? For a convex mirror, what's the sign of Q? What should it be when you solve for Q here? What sign should you be getting? Yes, negative. Now you don't want to put the negative because, right, if you look at your table, it says that Q is negative for these mirrors. But if you're solving for Q, don't make it negative. But if you don't, when you bring, when you're solving this equation, right? Because you're going to solve these both for Q1. When you get an answer for Q1, it better be negative. But I mean, look at these two numbers. How can it not? Right? It's pretty obvious to look at Q1 and Q2 just by the equation. And we got a negative F1 and a negative F1 and P2 and F1 and P1, right? So this has to be a negative number, right? There's nothing else that this can be but a negative number. But still, just make sure I'm just trying to make sure you understand the entire idea here. So, okay, so let's move forward. And like I said, we haven't even discussed the concepts for the third question. So we want to make sure that we talk about those concepts, and then we can try to solve a question for it. Okay. All right. So, and then I don't think we're going to have time to get to it. I hope we even have time to get to the question here, but I do have a second question here that if we have time, we can get to, but we'll see. And it's completely different than the one we just solved is the thing. Yeah. The second question, in case we don't get to it, just so you know, the second question I wanted to solve to practice the second question on the test, it's about the critical angle, okay, which is the angle of total internal reflection. And that's what the question was about. So I'm telling you right now, get to know that thing, okay, which is Snell's law. It's all based off of Snell's law. It's not just the critical angle in the question that you use. There's Snell's law, index of refraction, all these things. You use a lot of different ideas in there, but that's what the main idea of that question is about. So, but yeah, so this last section, as I was discussing, or as Dr. Asadi was discussing, or I was explaining this yesterday, was that it's really this chapter is trying to talk about, what causes light to bend other than indexes of refraction, right? and lenses. In this chapter, we're looking at uh, uh, well, I guess we're looking at diffraction still. We're not so much. We do take that into account at the very end, but this chapter is about diffraction and interference. That's the title of it. And so the first half of this chapter is really trying to describe more interference and diffraction. But then at the end, they talk, like the double slit experiment, single slit, that stuff. That's trying to bring both of the ideas together and talk about diffraction and interference, because based off the way the light bends, it's going to interfere with itself in different ways. That's what we see in the uh, uh, double slit experiment, single slit experiment. It's based off of how that slit makes the light bend. And that slit, it can't be just like any size. Like, the slit has to be close to the size of the wavelength of the light that you're using. So that the sizes of the slits are very important. Dr. Asadi doesn't talk about that, the double slit. He doesn't really test on, because I'll show you the equations for it, but that's why he doesn't test on it, because he doesn't test conceptually, and there's only two equations that go with it. And if you know those two equations, then you can answer the question on the test. But that's why he doesn't give it, because it's just based off of these two equations, and so he can't really make the question challenging at all, because it's like, these are the only two equations you use here. So keep that in mind. But I will, I'll discuss everything here. So the first part of this chapter is trying to talk about interference, and interference due to difference in path length. Okay, so when when something has, it doesn't have to have multiple layers, but at least two, right? And there's incoming light, as we've discussed before this with Snell's law. There's always reflection, right? This is the reflected ray, and there's always transmission. Okay, and then what happens at each each change of index of refraction. So remember, when we were discussing Snell's law, I let you all know that the every time there's a change in index of refraction, even though it's not like a surface, like a wall or something like this, it still works as a boundary. And so there's going to be, light's going to be reflected off that boundary. Even if this, like, what I'm trying to say is, like, imagine like this is air here, right? And then this is just like nitrogen or something like this. Like, even though those are two gases sitting on top of each other, there'd be a boundary in between them. And in that boundary, there'd be some reflection and transmission at that boundary. But in here, we're always comparing. There is some sort of surface, a hard surface to kind of work with here to make things easy. But what happens is that as these reflected rays start to let me do this. Start to bounce back based off of like how the index of refraction is changing. There's going to either be, it's going to have some sort of phase shift to it. So, and Dr. Asadi explained that to you yesterday, and it has to be a physics 1. It's not a physics 2 thing, but the wavelength can flip upside down if there's a phase change, right? If you're going from a soft boundary to a hard boundary, what happens is the wavelength flips. The wave on the reflect, like if you send a wave down a rope and it's connected to a wall, when that rope hits the wall, the wave is the reflected wave, right, is gonna be flipped. It's gonna have it's gonna be 180 out of phase is what we say. This is 180 degrees out of phase. Okay. And so that's what happens when you go from hard boundaries to soft boundaries. When you go from from soft boundaries to hard boundaries, when you go from hard boundaries to soft boundaries, there's no change. It's because there's no energy. Essentially what's causing the wavelength to flip is because the amount of energy that's needed to kind of anyway, the something going from a very large, a very high index of refraction to a very hard medium to a soft medium, right? It can do that very easily. What takes a little bit of work is to go from a soft to a hard, essentially. These are things you learned last semester, but we're taking that principle into this idea where now we think of the same way. So here, right, this wave is gonna come in, right? And then when it hits that boundary, there's going to be a reflected ray. Now this one is gonna have a 180 phase shift. So what we say, and 180 degrees is equal to pi, right? So on the unit circle, right? So we say that there's a pi shift here when it goes out of phase. But when we're going from a hard boundary to a soft boundary, there's no there's no I can't draw that very well, any phase change. Okay, and that's the important thing to realize. But again, here we're going from a hard to soft. There's not going to be any phase change. So there's just, this thing kind of gives you all the different things that could happen on here. So, and you could also get like pi and pi as well. There could be two, so like if you get let's see here, can I add that to this? Let me just do a different example. So I want you to tell me, because this is very, 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 very important in terms of solving the problems for the test. Okay, that's why you got to know how to do this. Okay, so I want you to tell me how the reflected ray, if it's going to go through a pi shift or if it's not, based off of the change in index of refraction. Okay. So we have the first ray comes in, and then there's this reflected ray. Is that reflected ray? This is the reflected ray. I can do it in a different color. This is going to be kind of weird. Right. So there's this reflected ray is the blue one. Is that going to go through a phase change or no? So it's in a soft boundary, considered a soft boundary compared to the next one, right? So it's going from a soft boundary to a hard boundary. Is there going to be a phase change or not? There's not. Oh wait, you said no phase change? It's going from a hard, remember what we just discussed? When it goes from a hard, that's literally the first, we just did that, right? When it goes from a soft to a hard, there's a pi shift, right? All right. I'm telling you, if you can't do this thing that we're doing right now is like the right hand rule. If you can't do this, you won't even be able to, like, you'll write the equation. There's the equations you can write down, but this is going to be part of the problem solving. And so you write down the equations, but you won't be able to do anything with them. Or you won't know which proper ones. There's essentially two equations that you can use here, and you can't use them both at the same time. If you write them both down, of course, Dr. Sadi is going to give you points because you have one of the right equations there. But, he's not going to give you as much as if you just have the right equation written there and not both of them. Like, it's like, I don't know which one it's going to be, but I know it's one of these two. Okay, and then we have transmission, right? And then what's the reflected ray going to do here? Is it going to go through a pipe change or no? Good. All right, and then there's go through again, and then the reflected ray, is it going to go through a pi change, or is it going to go through a phase change, or no? Good, because we're going now, those first two situations, we were going from a soft to a hard. Even though this one was hard to the top one, it's considered soft to the one below it. So both of these went through a pi shift because we kept going into a harder index of refraction, right? Or a harder medium or a larger index of refraction. That's what I should be saying. But now we're coming back out of it, right? Now this index of refraction, it's smaller than this one. So that means it's a soft boundary. It's going from a hard boundary to a soft boundary. So there's no phase shift there. Good job. And then what about the reflected ray here? Is that gonna go through a phase shift or no? No, because again, we're going, even though, this was soft to the top one, the next one, that's considered soft to the one that we're leaving, right? So that's going to be 0 pi change. Now, what you need to, this is only half the battle here, okay? The next thing to do is to recognize that there's constructive or deconstructive interference between your rays, okay? So you're never going to have, well, you might have these many rays, but what you need to do is you need to go through and look at how they're interacting. So these two rays right here, are they going to interact constructively or deconstructively? The pi and the pi. So they both went through phase changes. So that means they both flipped. What does constructive and deconstructive interference mean? What does constructive mean? Constructive interference. When two waves are what? So that's constructive interference. Okay. When two waves are what? They don't have to have the same amplitude, but they what? They have to oscillate together, right? I can't do this. Right, so those are in phase, and these two, they're going to add, and when they add together, it's going to give the wave that adds, the net wave when they constructively interfere is going to be larger than both of them, right? And so the green wave right there, that's constructive interference. The red and blue wave are going to constructively interfere to create the green wave, right? And when does this happen? When they're both in phase, which means there's no phase difference between them. So if two things go through a phase change, that means they're in phase. You might say, but they went through a phase change. Yeah, but they both went through the same phase change. They both went through a 180 phase change. So they're still in phase. They were in phase before they came in, right? Before they reflected. And then when they reflected, they both went through a 180 pi phase change. So that means they're still in phase. Does that make sense? Which means they're going to interact constructively. Does that make sense what I'm saying? Very important. And then deconstructive is the opposite. So it's where you have, two waves that, and they could be equal. Again, they could be equal in size, but they don't have to be, right? They're going to interact. But see, the blue wave is out of phase of the red wave. So it's gonna deconstructively interfere with it. It's gonna subtract some value away. So the net, which again is going to be the green wave, is going to look, it's going to be smaller than the red, but a little bit probably bigger than the blue. But that's going to be the result. The green wave is going to be the resulting wave of the red and blue interfering deconstructively because they're out of phase. Does that make sense? Okay. And again, I can't warn how important this is. We're going to start to solve a question here, hopefully soon. And I'm going to ask you these questions again. And if you don't know, I'm going to be like, we just did this in the review. They're that important. This isn't just for my fun right now. Okay. And what's causing this phase change? The path, this is the path length difference, right? They're going the path length of this one and this one, right? They're different, right? So path length changes, right? We can look at them. The path length changes can cause the waves to interfere constructively. This is what's causing the constructive or deconstructive interference. The phase shift is happening because it's going from one medium to the next. Does that make sense? But the constructive interference is happening because the difference, they're going to interfere because of a difference in path length. Does that make sense what I'm saying? Okay, because that's the idea, and that's what we see right in the equations, is that right. So we can write it a lot of different ways. We read it as d sine theta is equal to this, and then we can write d sine theta is equal to m plus 1/2 times lambda. And this lambda right here, do you know what this lambda is? It is wavelength, but it's something more than that. Wavelength of what? And it's very specific, just like everything else is in physics, right? So this wavelength right here doesn't matter the equation, okay? This wavelength, that's the wavelength of light in that specific in specific medium. So remember, we said that the wavelength changes when the speed changes, right? So when it goes into it goes from a small index of refraction to a large index of refraction, right? We know the wavelength changes, right? And it gets larger, right? Because it slows down. And this is trying to describe. So how do you write the equation? Do you know how to write the equation for that? So this lambda that we're this lambda down here, I want to make sure it's clear. This lambda, it's the same lambda in all of them, and it's the lambda, it's the wavelength of light in the specific medium that light is moving through at that particular time. And how do you write that equation? So this, when we write naught, that wavelength naught, this is the wavelength of light in a vacuum. So it's the one that you find on the spectrum that you look up on the on the internet. When you look up the electromagnetic spectrum, it gives you like a wavelength, like purple, right, has a certain wavelength. You know what I'm talking about? So this is always going to be a given, is what I'm saying. You should know this number because it's on every picture. It's all over the internet. It's in your book. It's everywhere. Does that make sense? So that's what I'm talking about, the wavelength that with the naught next to it. Okay. Now the n prime, that's the index of refraction of the medium that you're in. Okay, so you're looking at the ratio, the index of the wavelength of light in a vacuum, okay, to the index of refraction of the particular medium. Does that make sense what I'm saying? So like, like here, this is n 1.25. So you would put n 1.25 on the bottom and then divide it by, whatever wavelength, purple, whatever it is. You'll see how to use this. How you use it is, as always, can be a little bit more complicated than just like explaining the equation, but that's what that equation is. So make sure that you write all these equations down here. Whoa. All these equations down here, you need to write them the way that I have them right now. And then you need to go through and then put this in to each one of these equations, not just the top ones, the bottom ones too. Okay, like you should write this equation like this, and then you should write it with this in there. Does that make sense what I'm saying? What I'm trying to say, I'll give you one example, is that you should go through and like right here, just erased. Right here, you could say, d sine theta is equal to m over lambda naught over n prime. Okay, that's what I mean, because you might use this equation instead of just this one. All right. And that d sine, as you can see, that d sine theta acts as the path length difference, okay? And that d sine theta, you can look in your book, it's relating, so like there's an angle right here, and it's relating the angle to the path length difference. So anyway, I put the angle in the wrong place, but anyway, the point is, it's in your book. They derive it for you, but we got to move on here. So that's that's the idea, and these are the equations that go with the idea we just talked about. Okay, down here. Now, if you're not going right here, you see this equation on the right hand side. It has a 2 next to everything, right? And you could also write it as 2D. I didn't write it that way, but you could also write, you know, 2D sine theta is equal to m lambda, or 2D sine theta is equal to m plus 1/2 lambda. Okay, so, but when you write it with the 2, and he explained this in class, it's trying to explain the exact situation we were talking about, because the light's going to come, it's going to come in, so that's 1, right? That's 1 path through this medium, but then it's going to reflect back up, so it actually takes 2 paths, right? It's not just delta L, it's 2L. Does that make sense? So that's what these twos mean. So if you're trying to do your mathematics for this type of situation, which is usually the type of situation on the test, you want to make sure that you have not just L, because you'll look in your book and you're going to see this equation, and you'll look in your book and you're going to see this equation, and be like, well, those look like, what, one of them has 2 and one of them doesn't. What the heck? Which one do I use? Well, if it's this situation, you need to use the one with 2. Does that make sense? Awesome. Okay, so for those problems with the, Dr. Sadi was describing, he worked through that problem of like what colors you'll see, what colors you won't see. Well, those types of questions aren't very difficult, just as long as you use this. I made this chart, and if you study this chart, it'll lead you to the correct answer on the test. Well, what it'll do is it'll lead you to the correct equation you got to use. Okay, because as simple as this might look, it's actually not as straightforward. I think well, I guess that could be true said for anything in physics, but it's not. It doesn't. It's not as straightforward as It's one thing to talk about it. It's another thing to use it, right? And that's really all I'm trying to say. So I made this chart, and I'm actually trying to pull it out here, so that I want to make sure I give it to you, correctly. Because if I try to do, I made this chart up. After years of doing, actually, me and Dr. Sadi, believe it or not, me and Dr. Sadi made this chart together, and he might have showed it in class because we made it together, but maybe not, because I know he's moving pretty fast. So if he did, great, you're seeing it again because you see how important it is. If not, then know this chart, because it's one him and I made together to ensure that you use the correct equation on the test. Okay, so probably don't need. All right, so we're gonna have. Why do they keep doing this? Okay, we're gonna have these columns here, and then this column is gonna be what. Oops. What question is asking for? This column, the next column is going to be what does picture tell you? And then the third question is, or not question, column, is what equation you use. Okay, so these are the columns. Okay, so we're gonna do this make sure we understand. So the question, right, is the nice thing about this is there's only really two options to deal with. Okay, so the question is either going to ask you, do you see it? The question is going to say, or I shouldn't say see it, but the question is going to say, you know, what colors are missing? What colors do you, or what colors do you see? So if it's asking you what colors do you see? Do you see, or what's visible? Right, or essentially constructive interference, okay? When you have constructive interference, those are going to be the colors you see, okay? And then the other situation is, can't see it, right? Not visible, right? And when things aren't visible, they've gone through deconstructive interference. Okay, and so so for constructive, if the question is saying, what do you see? What's visible? Okay. And then you do your picture. Okay, so the next column is your picture. So that's what we were doing over here. So you might do your picture and you might get constructive or deconstructive interference. You might get your picture and you might get constructive interference. Does that make sense? So this picture, you're going to have to draw this picture every time for these questions. And you're going to have to figure out, based off the picture, based off the indexes of refraction and how they cause the change in path length, okay, you're going to have to figure out, is it constructive interference or deconstructive interference? Does that make sense? Because it could be either one. It can be constructive interference or deconstructive. And we went through both those situations. Okay, we went through both those situations, right? Deconstructive is when they're opposite, right? So deconstructive is like pi and 0. That's really the only option. And then constructive is going to be when they're pi or 0 and 0. Does that make sense? Right? Pi or 0, 0. Those are constructive. When they're opposite, it's deconstructive. Again, you're going to have to make these decisions on the test. So if it doesn't make sense, you need to be asking questions, because you're going to have to do this on your own on the test. And it's going to have to make sense. If not, you're not going to use the correct equation, because as you can see, you're going to have to draw a picture. Now, this chart that Dr. Asadi and I made, we didn't include we put the picture part in here because it's part of the problem solving method. We didn't make the picture problem up. We didn't say, oh, if students draw pictures, that's going to help them do this a lot better. No. It doesn't matter what class you're taking. You got to draw these pictures. So don't think it's a Dr. Asadi thing. Look in your book. We're going to tell you got to draw the picture every time, because you got to look at what the question's asking you. You got to look at what the picture's telling you. And then once you know those two things, you know what equation to use. So here, right, if it's constructive, you're going to use what we call the constructive equation. If it's deconstructive, you're going to, and remember, you can write this as 2L, however you want to write it. I'm not going to write it both. Well, if there's room, I guess I can. And then, right, and then, or you can write this as 2D lambda or 2L. Okay, so if the question saying what wavelengths are visible or what colors would you see, then that means you're starting with the first column here, and then you draw your picture, and then you look at your picture and say, my picture is telling me constructive, so then you're going to use this equation. But then let's say you do your picture and your picture tells you deconstructive, so then that means you're going to use these equations. Does that make sense? One of the two. I would suggest to use the L one, but right, I'm just writing it a few different ways so that you see it. Okay, and then what if the question says, okay, what wavelengths aren't visible? Which ones can you not see, right? Well, again, when you do your picture is going to either show constructive or deconstructive interference, because that's your picture. Your picture is showing you this based off what the question, based off the way that the situation's set up. And then, right, if it's constructive, this is where it gets a little tricky, right? So let's say the question says, okay, what wavelengths aren't visible? But then you do your picture and you see there's constructive interference. Well, you actually are going to use the deconstructive equation for that. Okay. And I know it's confusing, but that's why we made this chart. So like, don't worry, I know it's confusing, but don't, make it confusing. Just follow this chart every time. Okay. And if it's deconstructive, it's going to be the constructive equation. Okay. And also keep in mind, I'll write one of them, but remember, this is true for all these equations that we have written on the right hand side. That lambda can be written as what? Lambda naught over n prime, right? Remember, so that means you can write all these equations on the right hand side. You could go through and rewrite them all with this variable in them, because you should see it both ways. Because if you just write this is lambda, you're just going to solve this for lambda every time. But remember, this lambda you might have to use, which means you might have to turn it into lambda naught over n prime. Okay, does that make sense what I'm saying? So this chart is everything, and if you can't use it, it's going to be tough, okay? Because this is what's going to get you the answers on the test. All right, so that's the main part, actually, of the chapter that you really need to understand, or that can be confusing. Like I said, there is double slit experiment, but he might have even mentioned in class yesterday that he doesn't really test. Did he mention that he doesn't really test on that? Did he even get to it? I really didn't know where he ended because I had to step away. But how far did he get in class yesterday? Did he finish everything? Like, was he able to? I'm assuming, because he ended class early, so I'm assuming he did. But sometimes he'll just end class early. What was the last thing he talked about? You don't remember? You were dreaming. I know you're always making fun of everyone sleeping. So I think that's all you'll need to know. But I'll be honest with you. If he went a little bit further, well, I don't know. Actually, I'll be honest with you. That's actually all I think you need to really know. The only other thing that he might throw into these questions is fringe width. So make sure you have that marked in your book in case he talks about it. But this is really the complicated part. So that's what I want to focus on, because like I said, I have to end this session at 5:50. So we have 20 minutes left, and that means that we can solve a question. So that's what I want to do, is I want to solve a question. So let's see here, which one should we solve? Okay, let's solve this one. He has to. The thing is that if you're like, what are you trying to make a decision between? He's quite. They're so similar. I'm like, well, should we do that one? But this one's a little bit. I want to give you the trickier one out of the two, so that you see the most as complicated of a situation as possible. So okay, so here's the question. He says that white light illuminates from above perpendicularly, it's a big word, on the glass plate with different thicknesses. Okay, and he says which are T1 and T2. Those are the different thicknesses, okay? And there's a picture here that I'm going to draw in a second as well that he gives. And then he says the index of refraction of the glass is 1.5. He says find the thickness T1 and T2, okay, such that on one side the violet light wavelength 400 nanometers in air, and in another side, or on the other side, I think he put a typo there. Red light with wavelength 650 nanometers. Air reflect back. Okay, so and then the picture he gives is this, right? This is T2. He's asking for T2 and T1, right? This is T1. This is the glass, right? And right out here is air. So air has a index of refraction of 1.00. He says the glass index of refraction, right, is 1.5. And then he says, you have these rays, you can do them in color, where you have an incoming ray, but then one of them reflects, is reflecting back red. The other one, I won't be able to do violet. That was what I noticed when I started doing, but we'll say, I'll do that. Violet is the blue, okay? So he's saying that there's these two wavelengths coming back. So he wants to know what these are two different, you want to make sure that you're looking at this as two separate things, okay? because he's wanting to know the thickness on the left hand side and the right hand side. So you should consider this as two separate questions, essentially. Does that make sense? Don't look at them together. That's very important. I'm trying to hint you. Does that make sense? Okay. So how do I start this problem then? And also remember, I'll also give you this other hint, that this L, again, these equations over here, since he's asking this question this way, remember you can, the L is also T, so you could also write, this is 2T is equal to M plus 1/2, right? Does that make sense? Here, let me do that. So you can also say, 2T is equal to M plus 1/2, or you could say 2T is equal to M lambda. Does that make sense? So you can also write that, this in terms of T, and the same thing with the top, okay? Same thing with up here. Those, the D's and the L's can also be written in terms of T's. Does that make sense what I'm saying? Because that's what he's asking you to do. And I don't want you to be confused. I want you to know that 2T, 2D, they're all referring to the same thing, okay? So now I have them all on this graph for you. I don't have them in the correct, the two that I added, they're not in the appropriate. One should be for, make sure that you know, I guess I should put that this is for this one, and this is for this one. Okay, this is for this one, and this is for this one. Okay, know that. Those are ready. So, how do I solve this problem? What's the first thing I got to do? I got to draw a picture, and I got to, because look at this graph. This graph, I'm telling you, you got to learn this chart. If you don't learn this chart, you won't know how to solve these problems. This chart is telling you you have to draw a picture. So you know what the question, what's the question asking us for? Let me ask you that. It says white light illuminates from above perpendicularly on a glass plate with different thicknesses, right? The index of refraction of glass is 1.5. Find the T1 and T2, the two thicknesses, such that on one side, violet light with a certain wavelength in air, and on the other side, red light with a certain wavelength in air are reflected back. So is he asking us for, so the first thing you want to do, you read the question, then the next thing you do is you come and you look at this chart, and you start with the first section. This is written in order for a reason. Don't start over here. You might be, but I want the equation. Well, who cares? You can't get it if you don't know what's going on. Okay. What is the question asking us for? So is it asking us for what we see or what we don't see? Good job. What we see, it's saying like, they're telling us that wavelengths of violet and red are going to be reflected back. Those are the things we're going to see, which means we're going to see, they're asking us what we're going to see. So that means that in this chart, we need to start with the top, right? We're using the top, do we see it? This this part of the chart, we're working our way this way. So now we got to look at what our picture tells us. Okay, and this is for both situations, right? We're looking at what we see. Okay, so it doesn't matter what situation, but we got to draw a picture for both situations. So for the left-hand side, what is the reflected ray going to be? Is it going to have a pi shift or no pi shift? Remember, this is glass in here. Air has, 1.00. Remember, this thing's surrounded by air. Good, because we're going from a small index of refraction to a soft boundary to a hard boundary, right? I wrote 0, but I meant to write pi. Good job. Now, what about the next ray? Because you might be thinking, oh, that's it, but you forgot to draw that one. You forgot to look, right? There's going to be, don't forget the concepts. There's transmission here. So when there's transmission, what's this ray going to give us? The transmitted ray is going to reflect off the boundary, and is there going to be a pi shift or no? No, right? Because we're going from a hard boundary, right? The glass has an index of refraction of 1.5, right? So we're going from a small boundary to a large hard boundary to a soft boundary, and then from a hard boundary to a soft boundary. Sorry, I said that backward. We're going from a soft boundary to a hard boundary, and then a hard boundary back to a soft boundary. That's what I was trying to say. And so that means that because we're going from hard to soft, there's not going to be any phase shift. Now, what about the other side? What's the first reflected ray going to do for the other thickness? Is there going to be a pi shift or no? So we got the interference for the one thickness. Now we got to look at the interference for the other thickness. Yeah, there is, because it's the same thing as before. We're still going from air to glass, right? And then what about the reflected, the next reflected ray? What's that going to be? Right, no pi shift. So what does that mean? Remember, we're looking at these separate. Okay, we did them together because we should be efficient about this stuff, right? Because this isn't that challenging once you get it. So what is the left-hand side going through, constructive or deconstructive interference? The left, the thicker part. Is it constructive or deconstructive? How are the wavelengths interfering? They're interfering constructively, these two, on the left-hand side. What does constructive mean? Constructive means, we talked about this. Remember, I said, let's not have to do this. What is constructive? Constructive is when they're in phase with each other, right? In phase. Are these in phase? One has a pi shift, one has 0 pi shift. Are they in phase? Oops, not there. No. So what does that mean? Constructive or deconstructive interference? Good. And what about the other side? Is this constructive or deconstructive interference? Good. They're both deconstructive. Exactly. What does that mean? What equation do we use based off of our chart? So we know the question's asking us what we see. But then we know our picture's giving us deconstructive interference. So what equation do we use? Here he's asking us for thickness, so we use the what? This one goes down here. Remember, I wrote it up top because I was adding it at the end, but it goes down here. We use this one, right? 2t is equal to 1. Oops. Plus 1/2 lambda, right? That's the one we use, right? Awesome. And then he wants us to solve for thickness. So how do we do that? So the m's just an integer, but you're correct. We don't look for m though. Through concept we know what it is. Good point. That is the exact thing that we have to do first, my friend. Great job. So what is M going to be here? It's a concept. It's a concept. Think concept. So the concept here, because I got to go, I just noticed the time. So I'm just going to talk now and finish this up. The concept is that they're telling it, he's asking us what we see. So when M is equal to 0, that means those are going to be the brightest. Those are going to be the most visible. We can call it brightness as well, but those are going to be, in this case, we want to call them the most visible. When M equals 1, M equals 2, those we can also find other colors at when M. So what you can do is you can go through this equation after we're done here, and I let you go through and put M equals 2, M equals 3, M equals 4, and then solve the equation for the wavelength and see what other wavelengths you might see. These won't be as bright as M equals 0, but you'll still see these. Does that make sense what I'm saying? Awesome. Now he told us that he wants to see the wavelengths that he gave us in the givens are the wavelengths in air, which are the wavelengths in a vacuum. So he gave us lambda not lambda. Okay, remember I told you this was going to be important. He gave us lambda not lambda. So that means this lambda up here, we need to change it. And what do we change it to? Lambda naught over n prime, right? Where n prime is going to be equal to the glass, 1.5, index of refraction for glass. Okay, so what do we do here? This has to multiply in. So we see when we do that, obviously when it multiplies by 0, that's going to be 0. So really it's just going to be this, right? So it's going to be lambda naught over 2 n prime. I wrote that as n1. I meant n prime. And then you solve this for thickness. So thickness is lambda naught over 4, and right, this 2 is going to come down here and multiply with this 2, and this is the thickness equation. Does that make sense? And then all you do is put the numbers in there. N is going to be 1.5, and you're going to have 2 equations, right? This is going to be T1. T2 is going to be the same equation. The only difference is what? The wavelengths, right? This one right here is going to be 400. This one right here is going to be 650. So like I said, what I want you to do now, you can send it to me as to look over, but what I want you to do is use this equation right here, and instead of m being 0, I want you to make m equal to 1, and I want you to solve this equation for lambda now, this lambda naught. And I want you to do the calculations with m equals 1, m equals 2, m equals 3. And the lambdas that you solve for that fall into and then I want you to get the electromagnetic spectrum range and look at the numbers you're getting. If they fall in the visible range, that means those are the other colors you're going to see. And that's the other part of this question I didn't write. He just says, what other colors might you see? And the other colors you might see is when you solve m equal to 1, m equal to 2, m equal to 3, and you solve for lambda naught. Does that make sense? Awesome. Okay, I got to let you go because I got to go. But I'm super proud of you. Let me know if you have any questions. Send me questions. At least we solved through one of his tests. So you got a question from each part at least. But let me know what you need. Thank you so much. Have a great night. Bye.